next question is, where do we find ozone? Well, we find ozone both in the troposphere and in the stratosphere. In the in the troposphere, the concentrations are lower than in the stratosphere, and this graph is showing us the varying concentrations of ozone with altitude. Okay, this side is in miles, and this side is in kilometers. And you see that in the troposphere, by and large, up to about 9 miles, the ozone concentration is pretty low. We have this little red region right down here where it's a little higher. That is closer to ground level. Less than a mile high. That's some of the highest places in the United States that go a mile high, like Denver, Colorado. That's where we would have the concentration, red. That's where it would be done. The result of this higher concentration of the troposphere is down here closer to ground level. See, the concentration gets higher as you are lower, closer to the ground. That's because it's from man-made sources, right? And then it's pretty low for the rest of the way once you get away from where people live, because it's pretty high up in the sky. And so you get all the way up to about 9 miles, and that's where we reach the layer of the atmosphere that we call the stratosphere. And within the stratosphere, because the stratosphere goes on up, within the stratosphere, there's a region of the stratosphere where the ozone concentration is higher. Okay, and this is called the ozone layer. Now, sometimes when people think of layer, they think of a pretty thin, high concentration layer. But really, this layer is about 9 miles wide, and the concentration across those 9 miles varies. At the maximum level up here, it's about 12,000 parts per billion, and down here that would be about 100 parts per billion. So that gives you a sense of the scale. There's no units on this particular scale. It's just a relative scale showing the increase in ozone concentration. Okay, so it's showing that in the stratosphere is where we find a higher concentration at 12,000 parts per billion ozone. Now compare this to that first picture that you looked at. Where is it? The picture, right here we go. And I wanted you to answer some questions about, what are we looking at here? What's the scale? What's the story behind this particular picture? And in this picture, what you have is sort of images of how the concentration of ozone varies across the whole world. All right, so this is looking across the world, whereas this other graph was looking at altitude, the different ozone concentrations at different altitudes. And what this unit is, the Dobson unit, that's a unit used to describe the concentration of ozone. And the person who came up with this way to measure ozone, his last name was Dobson. That's why they call it the Dobson unit, okay? It's just because somebody came up with a scale, a relative scale to express the concentration of ozone. And as it turns out, one Dobson unit equals 1 part per billion ozone. Okay, 1 part per billion ozone. And that's sort of difficult to understand, because how are they measuring? Where are they measuring the ozone? So a better way to understand this is to understand the Dobson unit a little bit deeper. And the way he defined it is by looking at a column of the atmosphere. Okay, so the atmosphere, a column of air in the atmosphere, 1 centimeter square. So 1 centimeter is a very short unit of measure. So it's a tiny little space. Of course, that's not to scale, but you get my point. Like 1 square centimeter, and then a column all the way up to the top of the atmosphere. Okay, so when in this particular image, what they're doing is you can either measure this from the ground level up or from above the atmosphere down. They're scanning and looking at using satellites to scan and look at the total amount of ozone in this whole column. So if you're looking down on this column all the way up from 20 miles up in the atmosphere down, but it's a very small column, 1 square centimeter, looking at how much ozone is in that particular volume of space. Okay, it's a volume. It's it's 1 square centimeter. That's the cube, and then the volume, the length is the length measurement is like 30 miles, 20 miles up, something like that. And in this way, when we look at it this way, using this particular measurement, 1 Dobson unit in a column of air, given the number of total particles of air that you would find in that column, because remember, well, maybe you don't know this, but the closer you are to the ground level, the closer you are to ground level, the higher the concentration of particles. So we're looking at, as you get further and further away from the surface of the Earth, the pressure is less and less, and so the number of gas particles is less and less. So you're looking at the total number of particles in that very, very tall, skinny column, and in that regard, given the total number of particles that would be there, that corresponds to one in the column. 1 Dobson unit corresponds to 3 times 10 to the 16th ozone molecules, okay, in that column. So that's the scale that they're really using right here. They're sort of correcting for the fact that you have a column of air and you have billions and billions and billions of total gas particles, and of those billions and billions of particles in that column, 1 Dobson unit would refer to 3 times 10 to the 16th ozone. So here the scale is, the black is 125 Dobson units, so it'd be 125 times that number. That's the amount of ozone in the column in that little space right there. And moving up to the towards the equator, the green is about 275 to 300 Dobson units. So what this is telling you is that there's more ozone where it's green and less ozone where it's black and purple and blue. All right, so this picture, the story that's being told here is that the concentration of ozone in the columns of air that are all over the Earth is not the same. There's regions of the Earth where the concentration of ozone is less, okay? And that region of Earth is down here around the South Pole on this particular day, September 25th, 2006. Alrighty, so we want to understand, why is this story being told? Why is this story coming out like this, where there's a region of very low ozone concentration compared to the rest of the world? So we had to understand basically, what is a Dobson unit? What is this picture telling us? And it's just really kind of piquing our interest to the story, and we're going to spend the rest of these 3 weeks understanding this story so that when we look at a picture like this, bang, we know exactly what's going on. Okay? And I want to flip back to this picture one more time, just to make sure you understand the difference between the information in this graph and the information in this image. Okay? In this graph, we're looking at altitudes, and we see that within an altitude, at a particular altitude, the ozone concentration is higher. So in this way, if this were our column of air, say this is our column of air, our 1 centimeter column of air, then at the lower altitudes in this column, going from ground level up all these miles, we have, pretty low concentration at the bottom near the Earth's surface, but maybe a little bit more. Then very low concentration of ozone moving up the column. Then we have a region where the ozone concentration is a little bit more, and then less. So that's relating the column information that is used to make this picture with, in the column, where is the maximum concentration of ozone? It's towards the middle of the column. But when we're looking at this picture and this column, and we're saying the total amount of ozone in the column. You just have to know that that amount is sort of clustered at, around 15 miles high. Okay? So that's what those pictures are telling us. So that's where ozone is. That's sort of a long story, isn't it?